Okay, so similar to electric fields, there's something called magnetic fields. So what does this mean? Take a magnet for an instance. This is the south, this is the north. From the north, it flows out, the force. The magnetic field flows out, and the south, it flows in. And from the north, it will flow like this over to the south. All these lines around it are the magnetic field. So an interesting thing you have to understand is magnets have polarity. Magnets have polarity. So if there's a north facing a north, the magnetic fields will repel each other, like so. If there's a south facing the south, the magnetic fields will act like this. And if there's a north and a south, the magnetic field will just flow directly from one to the other. Notice the difference. In north, the magnetic fields flow away, pushing. From the south, they flow in, but at the same time, they still can't come together. You'll feel a force pushing them apart. But in the north, this one, the north will be attracted directly to the south. Okay, so now that we know how magnetic fields with magnets work, let's figure out how we can determine the magnetic force on a moving charge. The magnetic force is given by the equation force of magnetic field equals charge times velocity times the magnetic field in Teslas times sine of theta. The sine of theta is the angle which the velocity makes with the magnetic field. So, in this one, previously you have learned the right hand rule, which applies, and for a quick refresher, the palm, out of the palm, sorry, wrong hand, sorry about that, out of the palm is the force of the magnetic field, this is the direction of the velocity, and this is the magnetic field. And you use that to find different directions of the forces. Everything is perpendicular to each other. So now, how does this work in a practice problem? So here's one example of a charge moving through a magnetic field. So let's say the magnetic field is flowing in this direction. The charge Q is moving with the velocity in that direction and making a 30-degree angle with the magnetic field. So the value is Q equals 6 times 10 to the power of negative 6 coulombs. Velocity equals 4 times 10 to the 5th meters per second. And the magnetic field equals 0.4 Teslas. So as we previously know, the equation is absolute value of Q times velocity times B sine theta equals force of magnetic field. We just apply this here. So now the absolute value of Q, 6 times 10 to the power of negative 6 times velocity, 4 times 10 to the power of 5 times the value of the magnetic field times theta is this. So times sine 30 equals force of the magnetic field. When you plug all this in, the force of the magnetic field is 0.48 newtons. But which way does it go? So now we have to use the right hand rule. Right hand rule, so we have this. Velocity goes in that direction. Magnetic field goes this way. So the force of the magnetic field goes straight into the page, or in this case, the whiteboard. Now, to go on to another problem. How does a particle act within a magnetic field, and such as this one? So, in this one, the magnetic field is flowing straight into the page. For a quick reminder, X is going in, the dot is going out. Imagine it as an arrow. If you see the tail of the arrow, it's going in. If you see the point of the arrow, it's obviously coming at your face. Easiest way to remember it. So right now, say we have a particle moving with a velocity of v with a plus q charge. So right now, we have that the velocity is that way, and then you realize that the force, because with the right hand rule, goes this way. So since the force is going that way, it keeps on pushing it, and then you realize it constantly moves in a circle. So in this case, the path this particle would follow is like this. Sorry for my badly drawn circle. And this would be the force of the magnetic field. In this case, in these kind of scenarios, the particle has a centrifugal force coming from this. It's undergoing, centripetal force coming from the force of the magnetic field as it undergoes circular motion. So in this case, we can try to find, so in this case we can just set the equation to Q VB, since there's no sine theta, equals mv squared over r. Centripetal force equals magnetic force. And that's the motion of a particle within a magnetic field.